and why hydrogen as a fuel, and how to generate hydrogen, and how to use it as an effective fuel for the all kind of applications, especially in automobiles. There is the future using hydrogen as the fuel, replacing the fossil fuels. So coming to nanotechnology, the beginning was quoting a famous quote from the famous physicist Richard P. Feynman, which was, there is a plenty of room at the bottom. What it means is that if particles are made to small size in the order or size of atoms or molecules, they exhibit outstanding properties. So basically, nanotechnology is science and engineering at the scale of atoms and molecules. So I have a question. So what is the size of atoms and molecules? Or what is an atom or what is a molecule? Somebody can answer me so I can move forward.
Students,
Atom is the most undivisible part.
Yes. Yes, please. You can.
Uh, so atoms are very small compared to our normal objects.
Okay.
Uh, they are about the size of um, point not one into 10 into raised to power of 100 or something.
Okay. That's a good attempt. Someone else?
Molecule is a group of atoms placed together.
Sorry?
Molecule is a group of atoms bonded together. Like,
I, I couldn't hear you. Can you repeat?
a molecule is a group of atoms placed together.
Yes, yes. Exactly. Exactly. That's correct. So atom is the smallest building block of a material, which consists of a nucleus surrounded by electrons and a proton and a neutron. So nanotechnology is the manipulation and use of materials for fabricating devices so tiny that nothing can be built smaller. So it is the engineering in the lowest of the lowest. And nanomaterials are generally materials those have sizes between 0.1 to 100 nanometers. So that is a 1 nanometer is equal to 1 billionth of a meter. That if a meter is divided by 10 into or 10 or 1 with 9 zeros, it gives a nanometer. And particles with a size in between 0.1 to 100 nanometers are called as nanomaterials. And why we are so much interested in nanomaterials? Anyone can answer? Why nano?
So the nanomaterials give a lot of energy, and also nanomaterials can once we learn how to control them, we can do marvelous stuff with them,
Okay.
and
Oh,
they are related to also to the beginning of the universe.
yes. Yes. Yes, that's a very good answer. Yes, as you said, it has energies, very high energies, and it's one of the reason why we are so much interested. But because of this kind of size constraints, they exhibit also other kind of interesting properties. Like if they are made into so small, They exhibit unusual physical and chemical properties. For example, if a particle is made into such a small or a small size in the order of nanoscale, they exhibit high surface to volume ratio. And if they become smaller, there is an effect which is known as quantum effect, which became dominant. And because of this quantum effect, there are so many unusual properties exhibited by a material. So what do you mean by surface to volume ratio? For that, I have a figure here. Here you can see a particles. This is a bulk particle. So which is having a shape of a cube with size or dimension of 1 centimeter. So for this cube, the total surface area what we can get, that is the area exposed is 6 centimeter square. So this is for a cube with size or its dimension in 1 centimeter. So if we cut this cube to smaller particles, like small cubes with dimension 1 millimeter, the surface area becomes 10 times. That is, in the beginning it was 6 centimeter square, and when it is cut into small particles, it becomes 60. That it increased 10 times. So if it is further cut into small particles, that is in the area of, in the range of 1 nanometer, that if the linear dimension is in the order of 1 nanometer, it becomes this much, 6 with 70 centimeter square. It becomes 100,000 times what we got it as in the bulk. So if a particle is made into smaller and smaller, its surface to volume ratio increases. This is one of the peculiarity of making particles so small. So they can, because of this, a lot of area is exposed and we can manipulate them. I can show one example. This is a bulk gold. You all know what color a gold is. It's a shiny. But this shining yellow color is only happens when gold is in the form of a bulk. If it is made into smaller and smaller in the order of nano range or nanoscales, it is not in the color of yellow. This is a schematic representation of gold particles in different size. If a gold particle is made into 100 nanometers, the color is not shining yellow. If it is made to further smaller, that is 60 nanometers, it becomes a light pink. And if it is made further smaller to 15, it becomes a dark red, then to a brownish. And if it is made into in the size of atom, that is in the order of angstroms. Angstroms is a 1 meter divided by 1 with 10 zeros. That is 10 raised to minus 10 meters. It is in the form of a dark yellow, not the shiny yellow. So it is not the same when it was in the form of a bulk. All know that gold is a good conductor of electricity. But if it is made into nano size, it is not a conductor. It becomes a semiconductor. So I have a question. What is the difference between conductor and a semiconductor? Anyone can answer?
A conductor is like it's where it conducts electricity really well, and a semiconductor is where it partially conducts electricity.
Okay. And you can explain any particular property of a conductor? Did you ever encounter that kind of problem in your studies, like with temperature, something happens to conductor and something happens to semiconductor? If we increase the temperature, you know, Did you ever studied about that?
No, sir.
Okay. So for a conductor, if we increase the temperature, the resistance increases. But in semiconductors, it is just opposite. If we increase the temperature, the conductivity increases. That is, resistance decreases. So a gold becomes a semiconductor when it is converted into a nanoparticle. And also it exhibits different colors, and they are not metals anymore. Also, nano size gold is a good catalyst. What is a catalyst? Anyone?
So
Yes.
catalyst is a
Yes.
substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change.
Yes. Excellent. Excellent. Yes. Something that accelerates the rate of reactions is generally termed as a catalyst. So when nano, we are thinking like that it happened only in the recent time, but it's completely wrong. The use of nanoparticles where people of olden times, that in the medieval period, were using nanoparticles, but without knowing that they were or they are using the nano. Because in medieval churches, you can see glass windows with different colors. Actually, these were gold nanoparticles painted on glass. So people were using nanotechnology even in the ancient times without knowing that it is a nano. So when we start realizing that these are nanoparticles, it becomes a little more complicated because the engineering of nanoscale devices is not simple. So basically, the synthesis of nanoparticles is basically done using two methods, top-down and bottom-up. Top-down process is a simple process. Like we have a bulk material, so we can cut into small particles, and finally it reaches in the range of nanoscales. But this kind of approach is not that reliable because it have a lot of impurities because we can't cut in a specific or desired manner. Can you hear me?
Yes, sir.
Okay.
Yes.
In desired manner. So the mechanism of top-down, the synthesis of material using top-down process is not that reliable. We will not get our wish or according to our desire. They possess a high level of impurity, and this process is difficult to control. Also, there exist several kinds of structural and surface defects. Because if we are dealing with nanoparticles, this structural and plays a crucial role. So top-down process is not that much reliable in the fabrication of nanomaterial. So we are using a different kind of approach, which is called an bottom-up. A bottom-up process is that we use atoms to form a clusters, and then these clusters are transformed to nanoscale structures. Using this technique, it is very easy to control and make the particles according to our our wish or our desire. We can tune the size, morphology, and structure of the particles. So bottom-up process is mostly used for the fabrication of nanomaterials. And using this method, we can obtain homogeneous composition of nanomaterials with less defects. And this process is very easy to control. I have a question. So we are in a modern post world with using a lot of nanotechnology or nano devices. So someone can give an idea what kind of nano or nanotechnology you are seeing around you. Application of nanotechnology around you.
Maybe in hospitals.
in hospitals? Can you be
So sanitizers,
specific? Sorry.
sanitizers,
Yes, some kind.
Antimicrobial properties in like bandages.
Yes, there are some uses in that kind of. Other than medical field, anything else?
So Iron Man suit.
Iron Man suit, yes, is a fictional character,
Sir,
but
in UV protective elements,
yes,
in
it will be
sunscreens.
protected. Yes. Anything else? Any technological things, electronics, something?
Sir, circuits
What kind of circuits?
like computers,
Yes, computers. Okay,
computers, CPU, GPU.
yes. Anything? Anyone can add? Anything more?
So
Nano.
our electrical appliances.
Yes.
So also has
Okay. And now I'm going to talk about a most familiar thing you were encountered in last 2-3 years, which belongs to a nano-sized or
Is it a
nano.
vaccine?
It's virus.
Okay.
Viruses are naturally occurring nanoparticles. Those are in the size of nanoscale, like 0.1 to 100 nanometers. And also, there are other like antibodies or vaccines. You are correct. Vaccines are also a part of nanotechnology because they use nanocarriers to bring mRNA into cells to instruct them to make antigens and stimulate the immune system, which make antibodies against SARS-CoV vaccines. And there are also some other. Do you ever seen in this kind of clothes, like self-cleaning clothes? Have you ever seen this
Yes,
kind of?
sir, in some videos.
Yes. These kind of cloths are coated with nano silver particles because they have a repellent, anti-dust, anti-mud, anti uh, particle, like they can repel everything what is coming to the surface of the cloth. So there is no need for us to clean the clothes because usually we need to clean the clothes because it is attracted or it is the dust and sweat and everything get soaked by the cloths. But in this kind of cloths, they like because of these repellent silver nanoparticles, dust, sweat, and everything is get repelled, and will be no smell or anything. So we just have to put them in sun for some time, and we can use. We are putting it in the sun because there may be some bacteria, so sunlight can kill them. So in medical field, there are some use of nanotechnology. Like this is the most advanced level of applications with they are using nano robots for repairing blood cells. Also in other surgical and operational tools also they are using tiny nanoparticles like they are made into capsules which can be we can swallow the capsule or inject them directly to the vessels and they can repair the cells and they can eliminate it using like the excretion or anything. So the nanotechnology is so advanced like that we can repair even the blood cells using nano robots. And somebody already told about the circuits. So we already all know that 20 years ago, the size of laptops, electronic devices were not this much so this small because that time nanotechnology was in its state of developing. So now it has made a microprocessor up to this much small like less than like 1 milli. It's in the dimension of 1 millimeter. Like this kind of microprocessors are used inside a mobile phones, which made them thinner and smaller and compact. So these are the advancement of nanotechnology, which revolutionized a all field of science, like in electronics, in biology, and even in fabric industry also. So we can see that how nanotechnology has changed our life. You can compare it 20 years ago. I can see maybe you may not encountered with this drastic change, but for us, we have seen the change, how it changed. So it's a big change with the nanotechnology. So now I'm moving to hydrogen. So why hydrogen is that much important?
Sir, it laid the basis for our universe. Um, Hydrogen and helium were basically the first elements.
Uh-huh. And which is the
It
most
also possesses. It also possesses the greatest potential for energy resource.
okay? That's an excellent answer. Anyone?
So it's also very. It also has a very simple structure,
Yes.
and it's also very easy and it's very abundant.
Yes, that's a very good answer. It's the most abundant material on Earth.
So it
And
is the first element of the periodic table.
Yes.
so it's also uh, basically sunlight. How sun is being burnt up.
Yes. So you already know how energy is generated, right? In sun.
Yes, sir.
Yes. So hydrogen has a great potential of producing energy. Oh, as you said, it is the smallest and lightest element available, and it consists of one proton and one electron with no neutrons. And it is simply represented as 1H or simply H. And most common isotopes of hydrogen is deuterium and tritium. So I have a question. What is an isotope?
Sir,
Have you-
isotopes are basically the same material, but with varying electrons and protons in themselves.
Varying electrons and protons?
Number of.
Yeah, partially correct, but not. Can you like? Anyone can add anything?
Sir, also isotopes. Uh, they're the forms more two or more forms of the same element that contain equal number of protons
Uh-huh.
but different number of electrons, and they differ in atomic mass, but not in chemical properties.
No, atomic mass, no. They have the same atomic number, but different mass number.
Mass. Yes, sir.
Yes, yes. They have the same number of protons, but different number of neutrons.
Electrons. Yes, sir.
Yes, so that's correct. And the abundance of hydrogen, deuterium, and tritium is that hydrogen is almost abundant, 99.895%. And deuterium is very less, that is only 0.015%. And tritium only a small trace. So the application of hydrogen is so relevant nowadays because it is the cleanest source of energy with zero emission of carbon. You all know that we are facing a serious environmental problem because of this carbon emission, right? Because of the burning
Yes,
of
sir.
fossil fuels, a lot of carbon dioxide, carbon monoxide, and all kind of carbon particles are emitted to the atmosphere. which causes serious environmental problems. What are they? Can you just name some of them due to the
So
carbon
global
emission?
warming,
Yes, global warming,
Greenhouse effect.
greenhouse effect, yes. And because of that, so many things are happening, right? Ice are
Yes.
melting in the Antarctic, and the sea
Yes,
level
I
is increasing.
yes.
Yes, so many problems. So we need an alternative source with cleaner and sustainable energy. So hydrogen is considered as is the most cleanest source of energy with zero emission of carbon. Along with that, they can provide energy which is almost 3 times gasoline and methane can provide. So it is a great source of energy. And the cleanest way of producing hydrogen is through electro or photocatalytic water splitting. Then what it is. You all know that water molecule is made up of hydrogen and oxygen, H2O, right? So if we are supplying enough energy, that is if the energy is in the form of light or electricity, this hydrogen molecule water molecule can be splitted into hydrogen and oxygen. And it happens in the presence of a catalyst. So when a water molecule is splitted into hydrogen and oxygen with the presence of a catalyst, hydrogen can be collected. It's a process called a cathode and an anode inside an electrolyte, right? And when a water molecule is splitted, it can be collected at the cathode and oxygen at the anode. And this process is like if the energy supplied is electricity, this process is called electrocatalysis or electrocatalytic water splitting. And if the energy supplied is sunlight, it is or light, it is called photocatalytic water splitting. So pros of this kind of production of energy is that it can generate ideal fuel with cleanest byproduct. What we are using is water and what we are getting is energy, and the byproduct is again water, because we are supplying energy to split hydrogen and oxygen, and if we are trying to unite them, it will again release energy, and this kind of energy can be used as a source of energy or fuel for operating different kind of equipments. And you all know that hydrogen is highly abundant in nature, so there is no problem for getting hydrogen, and water is also abundant. So it's very easy to produce hydrogen from water, and it's a low cost process. But there are some other challenges also for this kind of application, because as I told, this process is happening in the presence of a catalyst. And the use of catalyst is to speed up the reaction and also the reduce the supply of energy for splitting the water. So as far as now, researchers are focused on an ideal catalyst to decrease the supply of energy and produce hydrogen and oxygen with less expense of energy. So like finding an ideal catalyst is a great challenge for the researchers, and we all are working to solve this problem. The next problem is the storage of hydrogen. You may know that hydrogen is highly volatile and explosive. I can show something which explain why I told like hydrogen is that much explosive, because hydrogen must be handled with so much care. All have seen hydrogen balloons, right? So this is a video of people celebrating someone's victory with hydrogen balloons, and someone lit the hydrogen balloon, and you can see what is going to happen. It's a violent explosion happening because hydrogen is explosive. So we must really carefully handle the hydrogen. So if you are using this hydrogen or store this hydrogen as a fuel inside a car, there is a lot of challenges, or there is a lot of risk of getting exploded. So that is also one of the serious concerns of researchers while handling hydrogen. So I already explained how what hydrogen is generated using water splitting. So it is a process of splitting water into hydrogen and oxygen with the expense of energy. So the energy needed for this reaction is almost 237 kilojoule per mole. And if sunlight is exposed to this kind of electrocatalytic cell, it must generate a potential which is equal to 1.23 electron volts for the reaction to start, that the water molecule to split into hydrogen and oxygen. The role of catalyst is to decrease this gap and make these reactions more probable or more easy. So more researches are happening in this area. And hydrogen produced has an efficiency of 70% using solar hydrogen or photocatalytic hydrogen evolution. And this is inspired from the photosynthesis process, where solar energy is converted to chemical energy. And in this process, catalyst is mixed with the water, and this catalyst reduces or accelerates the reactions and produces more hydrogen. So major challenge is I already told, to develop a high efficient hydrogen and oxygen evolution catalyst. We are going to discuss about the application of the hydrogen and oxygen we generated using water splitting. Have you ever heard about fuel cells? Anyone?
I have.
I don't know,
It's
but are
being
those
used like
the energy cells or something?
Yes, fuel cells. Yes, some kind of.
So they're like they contain a fuel in them.
Partially. What kind of fuel?
so the fuel cells are the ones that the kind of fuel they use is hydrogen, don't they?
Yes, exactly.
And it powers up
So
the
they
motor.
I'm sorry. Yes, somebody was telling something.
The fuel cells can also power up. Fuel cells can also produce electricity by the reaction of hydrogen and oxygen.
Yes, exactly. Correct. So this cell was introduced by Sir William Grove. He is known as the father of fuel cells. In the fuel cells, it is an electrochemical cells which convert chemical energy of hydrogen and oxygen into electricity through a pair of redox reactions. Redox means a reduction plus oxidation reaction. We inlet hydrogen and oxygen. This is a schematic representation of a fuel cell, where hydrogen is inserted through anode and oxygen through cathode, and there is a membrane separated these two materials. So anode and cathode, and there is a electrolyte in between. So here a hydrogen react with an oxygen, producing heat and energy, and throws out water as the byproduct. As you all know, when hydrogen and oxygen reacts, water molecule is produced, and during this reaction, heat and energy is released. This energy can be utilized for several applications. We can store in batteries, or we can use in used to run the motors or anything. So this fuel cells is working, and this kind of fuel cells is the basic building of hydrogen based automobiles. And the process of this kind of fuel cells is that they works at a low temperature and produces a high power density and easy to scale up. Like, we can produce this into an industrial level products very easily because the process is very simple. We need only hydrogen and oxygen, just combine and produce heat and energy, and this energy can be used for running motors in electric vehicles or hydrogen powered vehicles. So they are considered as the next generation power source for transportation or stationary and portable applications. Unlike battery, it never runs out of power, and it produces a continuous flow of clean power as long as fuel is supplied, that is hydrogen and oxygen is supplied. It will continuously runs and it will produces energy. And fuel cell vehicles are already demonstrated, and this is a schematic representation of a fuel cell powered. You can see there is a hydrogen tank, and you all know oxygen is plenty available everywhere. So we don't need to supply oxygen separately. We only need to pump hydrogen, which is from a tank, hydrogen tank. And here the reaction, what I show earlier, happens, and the energy that is produced, it is stored inside a battery, and this battery runs a motor, and this is how the engine work, and it powers the automobile. And the byproduct, what is getting out is the water. So instead of smoke, what comes out is just water. So it is the cleanest, eco-friendly method of riding a automobile. So these are some kind of models which already introduced in several countries, and there are more coming out. So finally, I'm going to give a small outline of the research what I was carrying out. We were fabricating two-dimensional nanoparticles, and I was using a material called molybdenum indium carbide. And we used a method called UV assisted phosphoric acid etching to produce two-dimensional layered material. And we prepared an electrode on a nickel film, and we used this setup to produce hydrogen, where we used a platinum electrode as a, it is a 3 electrode system. It is a little complicated. I'm just giving an idea how we are performing in laboratory. We use an electrolyte, which is a 0.5 H2SO4 sulfuric acid, 0.5 molar sulfuric acid, and we give a electrical energy to produce hydrogen in this is consist of 0.5 molar H2SO4 in water. So we will get bubbles, like the water is split into hydrogen and oxygen, and it is collected and stored, and we can measure. And this is the recipe of the material we were using to fabricate the nickel foam, and this is how we generate hydrogen in laboratories. So that's it from my side, and it's open for any questions. Anything, anyone can ask anything.
Sir, if hydrogen is easy to get, then why do they have to struggle to make more hydrogen stations?
I already told you that the storing of hydrogen is a great challenge. I saw that how explosive hydrogen is, that right? So we need to find some compact and safe, like storage facilities, or we need to like develop the system which can continuously generate hydrogen so that we don't have to fill the hydrogen. So if this water splitting is happening in the real time, we will get hydrogen all the time and we can supply it to the fuel cells. But the challenge is like that we are not even now able to develop a catalyst to reduce the amount of power needed to split the water. So we are in the developing phase, but in the coming years, we will be sorting out these kind of problems. And you can see in few years, like hydrogen fuel or powered cars is going to dominate, replacing the fuel cells. Fossil fuel powered cars.
Thank you, sir.
Sir, can we see future with these hydrogen cars? And if so, when can we see it?
Sorry, I couldn't hear you properly. Can you repeat?
Sir, can we see a future with ourselves and hydrogen cars? And if so, when can we see it?
It's already happening. In Germany, they already introduced hydrogen powered buses and trams, public transport facilities. So they are like refilling hydrogen from like we do in petrol bunk. They are fueling the buses with hydrogen. So in that process, like industrially, hydrogen is not produced using water splitting nowadays because of the low efficiency, because of inadequate catalyst. They are producing hydrogen using supplying energy like electric energy and producing hydrogen, which is not that much economical. So as an answer, like some Western countries has already introduced hydrogen powered vehicles. So the future is very near.
So what about India?
India is also introduced one hydrogen powered bus last month or something. I have read in newspaper. In Pune, they have introduced a hydrogen powered bus.
Yes, sir.
So,
Thank you, sir.
yes.
Students, feel free to ask. This is an interactive session. Teachers may also ask.
Does hydrogen have any part in nuclear power plants?
Deuterium has. Not
Deuterium.
hydrogen.
Okay.
Yes, the isotope.
Yeah.
Sir, is there any other food or gas that's also promisable as hydrogen?
You are already we are already using natural gases and liquefied petroleum gases, right? Because
Yes,
and the problem we are facing with these kind of gases is they are made up of carbon hydroxide, CH groups, right? So when they burns, they release a lot of carbon.
yes,
So,
sir.
so it's a great problem again for us. So as if now, no material is that much cleaner or eco-friendly compared to hydrogen. Hydrogen is more safest.
Sir, what are the problems while using hydrogen on a massive scale? What are the problems that we could face with that hydrogen on a massive scale?
The major challenge is the transportation and the storage. It's still a big challenge because as it is a highly explosive gas, we need to
Yes.
do more research on how to safely transport or store the. So, as if now the safety is the major concern when dealing with the hydrogen.
Okay. But it's still profitable, renewably profitable. Yeah.
Yes. Also, now majority of the hydrogen is not because of the uh, in like the catalysts are not that much efficient to produce hydrogen to an industrial level. So industries are still relying on other non-eco-friendly methods to produce hydrogen. So that is also a challenge. So people are working on catalysts to reduce or increase more use of water splitting for producing the hydrogen.
Okay, great. Thank you, sir.
Okay. Yep.
Sir, when they use like hydrogen on a massive scale, right?
Yes.
Sir, so like you said, they use a lot of eco-friendly waste. What are those wastes?
Actually, lot of industries are using or producing hydrogen from methane and ethane. They are hydrocarbons, right? So they are
Yes, sir.
they are using methods to separate carbon and hydrogen and producing hydrogen. So in that case also there is a release of carbon to the atmosphere. So that is one majorly now industries on all are relying on production of hydrogen from methane. So as hydrogen and carbon is released together or produced together, it is all again producing or creating problem to the environment. So that's the thing.
Sir, could you brief them about the opportunities that they have in research if they want to pursue a career in science or in research? What do they have to do after their education, formal school education?
Okay, so in my case, I like after my high school and higher secondary school, I joined a physics graduation, like BSc physics, and then I took post graduation in physics. So if you want to pursue a science career or getting into research, you have to be like little focused, but it happens after the post graduation. While you are doing the post graduation, you will be like little more focused or narrowed to a specific subject. Then you will realize what is your area of interest. Like if you want to pursue your career in teaching or research or something. In research also, you have two branches, like an experimental side. I'm talking about a physics research side. So in physics, we have two pathways. One is to the experimental side and one into to the theoretical side. If someone is good in mathematics and physics, and you want to like solve a problems like see, or you are very curious about things, knowing the things, you can opt the theoretical side and you can move or advance through the towards the theoretical physics and research regarding the theoretical physics. And if someone is really interested to do the things in an experimental site, like he want to do something physically and see the results, like for me it was like that. If I do something and if I get a result out of some experiments, I was so much excited about the things, and I want to know what is happening behind that. And in this case, you can choose the experimental side. So if it's the taste what you are getting or you are developing throughout your journey of education. So if you are in a higher secondary, you may, or in high school, you may encounter with some experimental activities, right? So in this, if someone is feeling interested in this kind of activities, you can develop the taste, and you can focus more on the subject. And which subject? If somebody will be interested in biological science, and somebody in mathematics, someone will be interested in the physics and experiments related to physics. So after your higher secondary, you have to choose, or you have to decide in which direction you have to go. Then you set a goal and then move forward.
Sir, small doubt.
Yes,
Sir, can this hydrogen fuel be used in spacecrafts and space missions?
actually hydrogen is already using in spacecrafts. Like rockets are fueled by hydrogen.
It's so like clean hydrogen fuel.
Yes, not like hydrogen is used as a fuel, but the production is majorly using what I said earlier from the methane.
Methane.
Not
Methane. Yes, sir.
methane. Methane.
Yes, sir, methane.
Yes. Yes.
Sir, is there like anyone who achieved success in mass producing hydrogen using catalyst?
As far as now, I don't know any company are claiming that, but people are working more. In India, the Reliance Industries are investing a lot in hydrogen. They are planning to like creating a boom in the hydrogen. So as I heard like that, they are investing a lot for the production of hydrogen, but I don't know which method they are adopting, but they are interested in hydrogen. So from my limited knowledge, I don't know like who is claiming the production of hydrogen using water splitting. But there is only a 4% still now. 4% of the whole production is done from water splitting now.
Okay, sir. Thank you.
Any other questions, students? Teachers? So,
I think Shindu sir, we are done. I think.
yes.
Thank
So
you
on
so much.
behalf of Indian Academy, we thank you from our bottom of heart that you spend some of your valuable time with us and enlighten these students and enhance their scientific method and research attitude. Thank you so much, Dr. Tijin Thomas. We look forward to more of your sessions in the future. Thank you so much, sir.
Thank you, sir. Thank you so much.
Thank you so much.
So much for inviting. Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir. Welcome.
Thank you, sir. Thank you, sir.
You're welcome.
Thank you, sir.
Can I leave, Shindo?
Yes. Thank you.
Okay.
Thank you so much.
Bye bye.